Okay, so we'll start. So before we start, I shall add one slide. Okay, so we'll make passes. Like first, we'll create the texture. So from the light, we'll kind of do the perspective or orthographic projection, and then whatever it comes. So anyway, as per the discussion, through GLUT look at GLU look at will bring the light at the center, but effectively it would be like from the light source. So we are making a projection, and then we'll have a kind of texture image, and in the final pass we'll see again. So first we'll see from the light source, and again we'll see from the light source, and per surface, per pixel, we'll calculate the depth, and then we'll match against the whatever texture depth we see, and then we'll decide that it is candidate of shadow or it is not a candidate of shadow. Okay, so we can start. Okay, I'll create a directory called shadow map. Okay, so first we'll kind of copy one skeleton, or we need to type everything. We'll see if there is something already, text.py. Okay, so so we'll kind of delete everything, whatever we want, we'll keep it. So we'll have a kind of init and GL clear color and shade model flat, GL enable depth. Okay, probably we'll see this. Then we'll have display. Display is very tricky here, so I'm going to close everything, and then we'll have kind of keyboard. Okay, so probably I'll add that later. Reshape, big thing, and then this. So this is a kind of a skeleton code for OpenGL, and dpkg-l python 3. Okay, so python 3 OpenGL we are using 3.1.5. so that is the scenario. So glut init and init display mode, we have single glut RGB. We'll add glut alpha. Okay, so we'll make it kind of 800 by 500, and okay, so it is shadow. So OpenGL shadow. Display func display. Okay, so keyword we'll use, or we can just okay, so just mask it. Reshape and glut main. Okay, so we'll start filling it. So we'll have shaders now. So we'll import from the shaders from OpenGL dot glut import star, GL dot shaders import star from OpenGL dot GL dot frame buffer objects import star. Okay, and we'll do some computation. We'll import math, numpy as np. Okay, then import math. From PIL we'll import image and we'll import RE also. Okay, so in the init we will init is a big thing. So in the init we will have GL clear color, GL enable GL depth test, very important. Now we'll have a frame buffer object, so equal to GL gen frame buffers. One will have, so we'll have here global because we'll keep using it. Shadow texture, GL gen textures, GL bind frame buffer, frame buffer FBO, GL active texture, okay, so texture 0 will make it active. So by default I believe it is not required. GL bind texture, GL texture, (2D) shadow. So this is a texture object. So we'll make reference to shadow texture object also. GL text parameter I and GL texture 2D, GL texture min filter and GL nearest. So we'll copy it. We did not type again and again. So min and max. Please refer our texture tutorial for all this stuff. Min and mag filter GLS nearest. We'll copy again and we'll have wrap S. So in S direction how it would wrap. Wrap S, GL clamp to edge and wrap ST, that is in Y direction. So wrap T, GL clamp to edge, GL text image 2D, GL texture 2D, GL texture. Okay, so now we are loading the image inside the texture object. So there is no image, so there is a special hash depth, that is component, GL depth component, shadow width, whatever shadow we are, shadow height, GL again. So this is the formatting. Otherwise we should have used internal format and the image format as GL RGB or RGBA, but here it is depth component, GL float, none. Okay, so shadow width and shadow height will, so here we'll say FBO equal to shadow texture equal to none, shadow width, shadow height. So we'll make kind of 256. So shadow width and shadow height, shadow width and shadow height, 0 GL depth component. Okay, now, so as we showed that in frame buffer there are many things that comes under frame buffer. So color buffer will mute it because we don't want, we are interested only in depth buffer to draw the texture. So we'll say GL draw buffer GL none and GL draw GL read buffer. So these are, they deal with color buffer. So if I set GL draw buffer and read buffer, then I can do kind of GL read pixel, and this kind of call I can make in the color buffer or the frame buffer. So GL frame buffer texture 2D, GL frame buffer GL depth, GL texture 2D, FBO and 0. Okay, so now we are attaching. So GL frame buffer, GL depth attachment, GL texture 2D and FBO. Okay, so now we are kind of this Mr. FBO, so that we are kind of FBO would kind of it would generate a texture image, so that we have already bind. So FBO frame buffer and GL bind frame buffer, GL frame buffer FBO. So this texture object is bound. Now we say that GL frame buffer texture 2D, so it would generate texture inside where we have bound. So if there is any error, so we can print. So if GL check frame buffer status, GL frame buffer not equal to GL frame buffer complete. If that is the case, then we'll kind of we'll shout GL frame buffer complete ext field. Okay, so that will print if GL check frame buffer status, GL frame buffer not equal to GL frame buffer complete. Okay, now it's time to unbind it. So GL bind frame buffer, GL frame buffer 0. Now as we saw, so we unbound it. Now we'll have display. So we have display. Okay, now in the display we'll have, so if uniforms equal to, so now we will kind of load shader. So uniform is a kind of a hash, I mean dictionary. So that is uniforms in the shader that is located. So at the beginning uniforms is like this. Okay, so that it checks, and if that is the case, then it calls load shader, so shader will be loaded in that fashion. Okay, so GL uniform 1i uniforms. So there is something called use shadow. So that will set to 0. So right now we are not bothered about kind of doing a shadow calculation. So this part we are not bothered. That is the final pass. Okay. So first we just concentrate on creating the texture. Then we'll see the final pass. So use shadow will make it 0. GL bind frame buffer, GL frame buffer FBO, and then GL clear, GL depth buffer bit. Okay, reshape shadow width, shadow height. So reshape, this function will get called, and GLU, so most important, GLU look at. So we'll have light position, so since it is used at many places, so we can just keep it. Okay, so the camera is in Y direction. It is pointing towards origin and here it is located. So this is the grammar of GLU look. Quickly we can see kind of like from OpenGL.gl import, GL import, we'll see if it is really there. GLU, OpenGL GLU star. So quickly we can find like GLU look at. Okay, so this is the help of GLU look at. So IX, IY, IZ, then where it is looking, center X, center Y, center Z, and what is the direction of the camera. So up Y, that is what we are making. So Python has everything, means so quickly we can do, we can check. Coding time is much quicker than any other language. So GL uniform matrix 4FV uniforms cam matrix. So what we are going to fill, false NP transpose, NP transpose GL get float V GL projection matrix, and then multiplied by NP transpose GL get float V GL model view matrix, and I think we are done. Now we will kind of GL load identity, and then we will call draw. So draw function will, two functions we have to develop, draw and then followed by shaders, GL bind frame buffer and GL frame buffer 0, GL bind texture, GL texture 2D. Okay, so we are GL bind frame buffer, GL frame buffer 0. So it is like we did GL bind frame buffer FBO. So it's like okay. So we are done. Okay, so this portion I think I can just leave it. saving to a file, and first we'll kind of draw it and then we'll see. Now GL clear, so this is final pass. So texture pass is over. So generating the texture is over, and we'll go to final pass. Then again we'll have the same idea, and then from light and then from the camera. So we are nearing. So GL clear, GL color, buffer bit, GL depth, buffer bit, reshape, shadow width and shadow height, GLU look at. Okay, so since we are doing same thing as we have stated, okay, so we are doing same thing, same projection matrix and same thing, so same thing we are doing. So we'll copy same code here. Okay, now there will be a bias. So idea is when we get the texture is kind of stored in 0, 1. Okay, so texture is lower left is 0 and then this is 1. This is how texture is. But now whatever we calculate, it is -1 to 1. So first we will make it half so that it will become -0.5 to 0.5, and then we'll add kind of some XYZ 0.5, 0.5 so that it will become 0, 1. So that we call it a kind of bias. So I'll say bias. So bias equal to np.array 0.5, 0.0, 0.0 and 0.0. Okay, so we'll keep adding. So 0.5 we are adding in the diagonal. So this shows that we are multiplying by 0.5. Okay, and now we are shifting 0.5, 0.5, then finally 1. D type equal to np float 32. Okay, so now we are ready for GL uniform matrix 4FV uniforms shadow matrix. So this will go in another calculation. False. NP transpose. So probably we can copy from here whatever we have written. So we are doing same thing. Again, okay, so NP transpose, and here we'll say NP transpose of the bias multiplied by NP transpose of the projection matrix and then model view matrix. Done. Story over. Okay, now we'll do GL active texture, GL texture 0, GL bind texture, GL texture 2D, shadow texture. Okay, GL uniform 1, uniforms shadow map, Okay, so we'll give a texture ID. So probably we'll give 0. This is what we are doing. And GL uniform 1 uniforms use shadow. Okay, so GL active texture 0, GL bind texture, shadow texture, GL uniform 1, uniform shadow map. So shadow map we are using 0 and use shadow, so we are enabling it. Okay, so we'll call reshape 800 600. Now GL idea is that camera should be at the origin, but we are kind of little bit we are transforming to look better. GL uniform matrix 4 FV uniforms cam matrix false. Okay, we can just copy paste word from here. GL load identity draw glut swap locus. Okay, now quickly we'll kind of write the shader. Def load shader global uniforms program equal to compile program compile shader. And now we can place uniform mat 4 cam matrix, uniform mat 4 shadow matrix, varying vec 4 depth projection, varying vec 4 color V, uniform bool use shadow. Okay, so now main will quickly finish. GL position equal to cam matrix into GL model view matrix, GL vertex if use shadow depth projection equal to shadow matrix into GL model view matrix, GL vertex, color V GL color, okay, GL vertex shader. Okay, now we'll type for fragment shader. Compile shader. Varying wake for depth projection, wake for color V, and uniform bool uniform sampler 2D, shadow map and uniform bool, use shadow. Okay, so now void main float shadow equal to 1.0. If use shadow, wake for shadow coordinate equal to depth projection dot w, distance from light equal to texture 2D, shadow map shadow code.st .z, if depth projection .w greater than 0.0, shadow equal to distance from light chord minus z minus 0.51.0, GL frag color equal to shadow into color V, GL fragment shader, uniforms cam matrix equal to GL get uniform location program cam uniform cam matrix uniform shadow matrix shadow map GL get uniform location program shadow map use shadow, uniform location program, use shadow, print GL use program, okay. Now we'll add draw function. GL push matrix, GL translate, light position. So light position I have to declare probably light position 1, light position 2. Okay, GL color, solid K2, GL pop matrix, GL push matrix, DL translate, GL color, select wire sphere, okay. So idea is to draw a sphere and that to map on kind of another cube, big cube. So GL push matrix, GL translate 0 minus 20 0, GL color 0.5 0.5 0.51, glut solid Q 40, GL pop matrix, GL push matrix, GL color 1, GL translate 1880. So we are drawing one kind of plane. GL rotate minus 10, GL scale, glut solid Q, GL pop matrix. Okay, so this is how it is. GL pop matrix, glut solid Q, and 40 minus 10, 18. GL push matrix 20 0.5, 0.5, 0.5, Q40. Okay, and then we have GL clear color, so white, size 2, pop matrix, push matrix 10, blue color. Okay, so we are done. So light position will set. We have not set. Light position equal to 0, 20 minus 20. Okay, so I think I would describe this draw more when we see the output. So kind of it is more rational. Okay, so vertex shader has a compilation error. Depth projection color V, use shadow, cam matrix, GL position if use shadow, GL color, shadow matrix, depth projection. I think it's alright. What about this? Depth projection color, shadow map, and then use shadow, shadow, use shadow, depth projection, distance from the light, and if depth projection then 0, then light, GL frag shadow color V. I believe it's alright. Okay, glut. Bias not defined. GL uniform not defined. Uniforms not defined. And we get it. Okay, so I believe I have not resized it, but this is how the output is. So we can see kind of one wireframe, and light should be visible. Yeah, so it's visible. So this is light source, white color, and it is placing light. So the camera is not at the origin. Okay, so camera is also at some height, and this is the shadow we can see, and then kind of so we will change the light position. So this is one surface, we can see this is one surface, and this is a table kind of. So sphere is kind of in sky, and then light falls on the sphere and we can see the shadow. Okay, if I move the light here, Okay, then shadow should come here. Okay, light is at 20 and minus 20. Okay, so 20 is y and minus 20. So idea is that light will move it to 20 minus 20. So we'll see if it comes. Nice one. Okay, so if light is here, then it falls on this surface and this surface. Okay, we'll kind of make light source minus 20 is, I believe it's alright, or make minus 40 or 20. Okay, what I'm trying to do is okay, so we'll reduce this. Now we'll see. Okay, so we can see the light is, I want to bring it on completely on this plane. So this is what I'm trying. Probably I'll make it even less. I'll make it more. Let's see. Wow. So light is falling, but we can see this is, so we'll make the angle more. We'll see GLU perspective. It is 45. This is what we are trying. We'll make it 60 so that it will be broader. Okay, so origin is somewhere here. So we can see shadow falling on this. Okay, so this side. So when camera is here, then it is looking at the origin. So when camera is here, it is looking at the origin. So this is coming as a kind of sideways. It is not looking at the sphere. Okay, so that is the scenario. Okay, I'll try to bring it near if something changes. And some 5. Okay, height I believe I can decrease. I'll try. Okay, so it is not showing, means it is not coming the picture. So what camera is kind of is seeing, so that will try to kind of make it. Okay, so minus 20, and then we'll make more. We'll try minus 10. Okay, so shadow is falling here. Okay, so now I think it's okay. So now we'll show the code and then we'll proceed. Okay, so in the code we have light position and then we have shadow map. So in this directory we have only this program, text.py. Okay, if we want a bigger picture, then we'll make it small again, kind of 45 or try 30, how big it would be. Okay, so certainly it is more clear, but our light source is not in the view. This is problem with GLU perspective. We'll try with 40. Okay, certainly it is better, but again our light source gone. Okay, so we'll try 45 only. Okay, so I believe it should not be unhappy much. Okay, so better. So light is falling on this sphere and then it is getting drawn here. Okay, so more I'll shift it to, so that shifting we'll see. Now we will kind of see the code. So in it, so we have a frame buffer, and then we have one texture object, and then texture object property we are assigning nearest. Okay, and then we have a kind of texture object loading of the image. So instead of loading the image, we are specifying it is depth component and shadow width, shadow height, and then it would fill the value as float. So that is the idea. Color buffer we are kind of shunting it, and then we are kind of generating the kind of saying to generate the texture. So texture is bound to this frame buffer, and then we are unbounding the frame buffer, unbinding the frame buffer. Now we are drawing cube first, that white cube, that is the light source that we saw, and then okay, so we are shifting minus 20 and we are drawing 40, so that is a table where the shadow is coming. So that we are trying. There is one more. So this is light cube, and then this is the wire sphere, blue color, then this is the table, and this is the yellow color plane on right side that we are seeing. Okay, now in the display, first we load the shader, and then we bind the frame buffer, and binding the frame buffer, we first generate the texture map. Okay, so that is the idea. Okay, so uniforms, use shadow. Okay, so that we will see in the texture. Now we are saying look at, and then we are filling the projection matrix. Can we see like the projection matrix and model view matrix that we are multiplying, and we are setting as a cam matrix. Okay, and then loading identity, and we are drawing it. So whatever we are drawing, it is coming into frame buffer, and whatever we are drawing, so that drawing is happening through the shader. So we have kind of two matrices, cam matrix and shadow matrix. So initially we don't use shadow. Okay, so only cam matrix. So cam matrix in the sense that light we are behaving as a camera, and we are doing GLU kind of GLU look at. So cam matrix we are filling. So this is simple. This code is not getting executed at all. Use shadow. So this is for final pass. So for the creating the shadow to create the shadow texture, only this line is enough. So cam matrix, whatever the current projection and model view, that we are multiplying and setting it in cam matrix. When we call draw, whatever is the new projection, and that anyway that is new model view that is coming in model view matrix, and whatever the vertex is. Okay, and there is here at the beginning only we have used shadow, so there is no meaning now. So when we trying to draw the texture map, only this line is valid. So cam matrix and model view and GL vertex. So whatever we receive, so that is placed inside the texture, so that we'll see how the texture looks. Okay, then we can tweak more the light position. So what we are doing is, first we are reshaping shadow width and shadow height. So reshaping is nothing but setting the viewport and projection load identity, and then we are setting projection as GLU perspective, and then GLU matrix board model view and GL load identity. So reshape is nothing but kind of setting the projection matrix and loading the model view and setting the identity and setting the viewport. So first we set all those steps. So this is the simplest possible line of code that we have written. Okay, it is kind of will be much bigger at other places. So it is a kind of a place where it should be referred. Okay, so reshape, shadow width, shadow height. So model view is load identity. Now model view are filling at through GLU look at, and then GL uniform matrix. So here the cam matrix in the shader we are filling as multiplication of the projection and model view, and we are loading the identity. So whatever we have filled in the CAM matrix. So now our model view is completely empty now, and then we draw. So if we call draw, then it would refill the model view. So this is okay. So if I say GL load identity and then call the draw, then it would refill a complete model view matrix again, and whatever it refills, if we go to shader program, then CAM matrix anyway we are setting as per the kind of camera matrix, that is the light source. So when we do the look at, okay, so when we do the look at, then this light source we are transforming it to center. Okay, that is the look at that we have seen. Okay, so this is the CAM matrix we are setting after look at. Then we are then model view matrix, that is the draw function what we have seen, and vertex. So vertex, model matrix, and CAM matrix multiplication of the projection and the look at model view, and this we'll see. So this is what we have done. Okay, and then we draw and then we unbind the frame buffer. So idea is that since we have called the texture 2D, we have called the frame buffer texture 2D. So frame buffer is bound to draw everything into the texture. So depth value is coming as a texture pixel value. Now we are clearing the color and depth buffer. Okay, and we reshaping it, calling GLU look at, and now as we talked that the image what we get, the texture, so that is 0 to 1. The image is 0 to 1, not minus 1 to 1. So whatever we generate. So again we are doing reshape, and then GLU look at same light position. So this is the second pass. So first pass we saw first term, inside the first term we are creating the texture map. In the second pass again we are calling same thing and trying for each pixel we are trying to get the depth value, just depth value. So bias is required because so bias is required because we are converting. So now whatever we are drawing, that is in minus 1 to 1. So first we convert it to minus 0.5 to 0.5, and then we will add some kind of translation, and so that it will shift minus 0.5 to 0.5. So we'll add 0.5. So it will become 0 to 1. So that is the kind of biasing. Okay, so 0.5, 0.5, 0.5 is making it half. This is identity kind of matrix, and then we are setting the bias 0.5, 0.5. So first making minus 1, 1 as minus 0.5, 0.5, and then minus 0.5, 0.5 to 0 to 1. So that is the idea. Once we do, then again we go for multiplication of this bias, and then projection, and then model view matrix, and we set it to shadow matrix. Okay, so and then after that time comes for the final pass of the actual camera. So these are light camera, actual camera. So first the shadow texture what we have received, that we set, and then we enable the use shadow. So use shadow is 1 now. Okay, and shadow map. So there are please refer texture tutorial. So there we have texture units. So we are enabling texture unit 0, and then we are enabling use shadow, and then we are reshaping with our window size, and then we are shifting the actual camera also at 60-60. Later we'll try to place it as 0-0. This is what the actual design is, that camera should be at 0-0 fixed. But this also we have to look better, we have shifted through GL, not required. And then CAM, again we set the CAM matrix and transpose model view, and then load and then draw again, and then glut source. So when we drawing again, now pixel by pixel it is drawing. So if red color is the pixel, then for this pixel we draw all the analogy that we have shown. Okay, so that is the idea. Now if we go to shader programming, then we are enabling the use shadow. If we enable the use shadow, then we are calculating again same thing what we did in CAM matrix, shadow matrix. So here bias into projection into model view, and model view matrix would come from the draw function, and depth projection, this is how we get. And whatever the color we are getting, the color we are setting through the GL color. And in the fragment shader, what we do is that the texture value, whatever we receive, so in the texture value, we read the each texel value, that is the distance, and whatever the we receive. So there are two things. One is the texture value that is stored, and second thing, whatever the distance we are getting in the second pass. Okay, so this is the distance in the second pass, that is shadow coordinate, and distance from the light, that is from the texture. Now, if texture is less than shadow coordinate, okay, then the object is on right side, so it should be shadow, that is 0.5, okay, and otherwise it should be kind of white. And then fragment color we set whatever shadow we are getting with the color we. Okay, so as we discussed, so this is 1 we are setting, so 5 we are setting. We can kind of a shadow, or we can set a color also, or we can kind of set it as okay, so we can change the kind of intensity of the shadow. So in shadow would look kind of less gray. So that is the concept. And then we set all the uniforms to whatever uniform location we are setting. We have printed it also. That's it. Now we will kind of move the light source, and then we'll see how it looks. So this is the smallest possible line of code in the kind of in shadow. Okay, so this is the concept. So we'll go to initial and we'll see the output. This is our 30, we'll keep it. Okay, so this is the initial output, and Mr. Light source is missing because we set it again too high. Okay, so we'll make it really. Okay, so light should appear. So this is light source. Okay, and it is falling, and this is the shadow. So the shadow acne that we will discuss later. So can we see that these are the lines that are coming? So these are unwanted thing that we are seeing. So that will cover to how to remove these lines and how it appears.